have place? No, two more people are going to come in. Better two more people. Two more people.
Shalom. Very happy to be here. I had a wonderful tour. This is my first trip to Israel, and it's been very, very special. Got to see Jerusalem and the Old City today, and it's just very moving and wonderful for me. I got to see Israel from space. I'll show some of that, but it's a lot better to see it face to face. So anyway, I have a lot. By the way, if I start talking too fast, just kind of raise your hand, and signal for me to slow down, because I love the space program very much, and I can talk, and then I get excited and I tend to talk too fast. So anyway, as was said, I was picked to be an astronaut in 1978 as part of the first group of women selected, and I'll talk to you a bit about that. So what I'm going to do is just talk to you a bit about what it's like to be in space, a life like, and then I'm going to talk a bit about the space station, which maybe some of you in this audience might like to go be on someday. Is that better?
You'd rather stick with that?
Is that better for everybody?
Yeah.
Better? Okay, yes, I'll do that. And then I'll talk a bit about where I think the future of the space program is going. So I'm going to go ahead and get started. First, I always like to tell people, because I get so many questions about where we live. I'm from Houston, Texas. The Johnson Space Center is the home of manned space flight. This is where Ilan Ramon came and trained with his crew, and I'll talk a bit more about that too. But the Space Center is kind of like a college campus, like the university here. It always reminds me of that. As I said, I was selected to be in the first group of women astronauts selected in the United States program. Of course, 2 Russian women flew before we did, Valentina Tereshkova and Svetlana. That's Dr. Shannon Lucid, Dr. Ray Seddon, Dr. Kathy Sullivan, Dr. Judy Resnick, myself, and Dr. Sally Bryan. This is when we were doing our water survival training. One of the most fun things that happens once you get assigned to a crew is you get to design your patch. And so we worked on designing my patch, but because I was the first mother to ever fly in space, we had 5 stars for the crew members, for the 5 crew members on board, but then I added a star for my daughter. When I flew, we didn't wear the orange pressure suits that you see the crews wearing now. We added those pressure suits after the Challenger accident. We flew just in flight suits, very similar to what I'm wearing right now, and we flew as a crew of 5. Later crews flew with a crew of 7. Just before you launch, the process from when you're selected to fly on a shuttle flight was about a year of training, and for that entire year, you have hundreds of hours in the simulators, and I'll show you a bit more about that. But then about a week before you go to fly in space, you get into quarantine so that you don't pick up any illnesses, since so much money is invested in your training, and we did not have backup crews. And then about 3 days before launch, you fly to the Kennedy Space Center and get ready to go into space. We had a 1-day delay before we went out to launch, but the winds at altitude were too high. So the next night I flew on the shuttle Discovery. One of my favorite memories was Dr. Joe Allen, who was one of my crewmates, and I drove out to the pad to take pictures and go around. And I can't tell you what it's like the night before to go out and see this rocket ship on the pad, know that you're going to launch on it the next day. It's really exciting. Traditionally, on the morning of launch, you have breakfast, although most people are very careful to not eat very much on the morning before you fly, and very careful not to drink very much, because no matter how careful you are, when you're out on the pad for 3 hours laying on your back, you're going to definitely have to use the bathroom, and there's no bathroom on board the shuttle until you get in space. So this is just getting ready to get in. Whoops, sorry about that. And this is what it looks like inside the shuttle. If you imagine your chairs laying on your back, is what it's like just before liftoff. When the shuttle lifts off, there's over 7 million pounds of thrust. There's the 3 main engines gets the fuel from the external tank, which has a mixture of hydrogen and oxygen, and then the 2 solid rocket boosters on either side. That's the flame when you look out the back window. It's like 700 feet long, and it's a nice thing that you don't really see that from inside the cockpit. And at about 2 minutes into flight, the solid rockets fall and are later recovered, and all the parts of the shuttle are reused with the exception of the large external tank. And there's the external tank, and then that falls back into the atmosphere and burns up. I'm going to try to show you the now video of ascent. The 3 main engines ignite at about 10 seconds prior to liftoff. And then at T0, when the solids ignite, you may not know where you're going, but you definitely know you're going somewhere in a hurry. You feel every bit of that 7 million pounds of thrust. For the first stage of the ascent, it's very loud, lots of vibration. You can see the shaking from inside the cockpit. Once we clear the pad, we rotate to put us in the correct attitude for inserting into our orbit. And it's just it's hard to describe just how much power is involved in the ascent. As I said, then in about 2 minutes into the launch, the solid rocket boosters are jettisoned. And after that, it is just as smooth a ride as you can imagine. All the noise, all the vibration goes away, and it's just a steady acceleration up to about 3 times the force of gravity. And then at about 8.5 minutes, the main engine shut off, and you go from 3 Gs, 3 times the force of gravity, to weightlessness, to 0 G in an instant. And you can almost feel the blood rush from your legs into your central system. And if you see pictures of astronauts shortly after they get on orbit, you'll see that their faces are really full. For some of the older folks in the audience, it's really great. You get rid of all your wrinkles and everything. Unfortunately, they all come back when you land again. But it's and then many, probably 50%, I think it's even more than that, of astronauts and cosmonauts have what's called space adaptation syndrome, where you really don't feel very well for the couple of days, and I'll talk a bit more about that in a second. The space shuttle, and what I know the shuttle isn't flying anymore, but a lot of the aspects of space flight on the shuttle, or whether it's a Soyuz or whatever manned spacecraft come up with, a lot of the ideas are the same about what it's like to live in space and the challenges you're going to face. So I'm going to tell you a bit about my flight, but then I'm going to go on into talking about the space station and some of the things that are happening right now. On board the space shuttle, it's like a 2-story, very tiny apartment, if you will. The upper deck looks very much like a cockpit of an aircraft, a 747 or any type of aircraft. We carried several hundred pounds of checklists. We had checklists for everything. This was your Bible on board the space shuttle. It had every detail of everything you were going to do for the entire mission, and you followed it very carefully. Once you got on orbit, we took out the 2 seats that are the mission specialists 1 and 2, like I had. I sat in the seat between the commander and pilot. And we folded them up and stowed them out of the way so we had more room. Because when you're on orbit, then this is where the commander would fly the shuttle, as we were getting ready to either dock with the space station, or in my case, we were going to pick up 2 satellites that were in an improper orbit. And then I was the arm operator, and from this side, you could operate the robotic arm. Then there was a mid-deck area, which is the lower deck, and this is where we kept all of our food, our habitability, any experiments that we carried on board were all on the mid-deck. Here you can see that I'm holding on to the handle of our treadmill. On my particular flight, we didn't have a galley, so we had this little suitcase that was used to heat our food. And it's interesting, as I'm getting ready to work on our next vehicle, the Orion vehicle. It's like the shuttle back in the early days that didn't have a galley, and we're going to use that same suitcase again on the next vehicle. So interesting. Once you got on orbit, we each had our own lockers. Everything was color-coded. Red, as you saw on that checklist, was for the commander, yellow for the pilot. My color as Mission Specialist 2 was green. Everybody brought their little tags from where they went to college, or which part of the military they served in. I had a picture of my daughter. You can see it's weightless. I wore that necklace in space. And also you can see the 0G hairdo. A little bit about food, and I'm going to show you a video of that in a second. But the food on board the space station, on board shuttle and on space station and on the future vehicles, is very much like backpacking food. You can see here that we would just hydrate things. And you'd have a tray like this, and you'd have the straws, of course, had to have a check valve, because if you left it open, you'll see in a moment in the video what happens if you're not very careful about and being disciplined about your food. Dr. Joe Allen was a physicist. He said he was studying fluid dynamics in this particular slide. A little bit about sleeping in space. I'll remember very distinctly the first night when I was up on orbit. It's just such a strange foreign environment. The analogy is like when I traveled to Japan, and you come into a ryokan, a Japanese hotel, and you come in and you don't know where to put your suitcase. It's just very unfamiliar. Well, space was very much like that. And that first night, sleeping in space was very difficult. Not difficult, but just, it was a very foreign environment. I slept wedged between these two. There's two sleeping bags, and the pilot, Dave, slept here, but the other crew members had flown on previous missions, and they just slept wherever they happened to be. Dale Gardner liked to sleep in the airlock, and the commander wanted to stay in his seat in case there was an emergency overnight. So everybody else just kind of slept free-floating. But this is like on the 8th day, just before we were getting ready to come back, and I'd actually fallen asleep here. It was a pretty busy mission. I was taking a little nap. And you can see I'm just tethered to the handle of that treadmill. So it really doesn't matter, like if you wanted to sleep, you just go to sleep, because you're not going to fall and hurt yourself. A little bit about how you go to the bathroom in space, because everybody wants to know, but is afraid to ask. This is what we call the waste management system. Dave is our pilot, and hopefully he's just simulating here. But the waste management system is kind of like the porta potties that you go to when you go to a festival or a fair or something, the little outdoor potties. It's kind of like that, only it uses vacuum suction to kind of help things along. And you really have to spend a lot of time on the ground practicing your aim to make sure you do everything correctly. And we actually had a checklist. You can see right here, he's holding that checklist. And this is one procedure you do not want to mess up. The one thing that NASA added when we started flying male and female crews was the privacy curtain. But as you can see, it really doesn't give you a whole lot of privacy. People can kind of tell what you're up to. So you get to know your crewmates very, very well, let me tell you. I'm not going to spend a lot of time talking about my flight. I will say that it was a very exciting mission. Before the Challenger accident, we launched communication satellites, so we launched 2 satellites, and then we had the pleasure of going up and being the first crew to go rescue hardware. And there were these 2 satellites that were about the size of one of the small school buses, that their motor that was supposed to take them to geosynchronous orbit failed about 4 seconds into what should have been a 4-minute burn. And so we got to work with the engineers to develop the hardware and the procedures to go and get these satellites. And you have to realize they were lost in February of 1984, where they had their problem. And we launched in November 8th, which is a very short time for NASA to have developed hardware and procedures and training. And so it was really exciting. It was, I couldn't have picked a better mission to be on. And so here you see Rick and the commander, and I'm looking over our procedures, getting ready to go get the satellites. Here you see Joe Allen, who was EV1. You can tell because he has the red indicator on his suit. And I was operating the arm as he went out and grabbed the satellite and then brought the satellite back into the payload bay. I'm just going to show you a quick video. A lot of the same things I just talked about, but it's really kind of fun when you see it actually moving. Sorry, I don't have enough hands here. Here you see Dave. This is on the day before our deorbit burn, where they're going through the checklist to check out all the flight control systems. As I said, checklists for everything. We're always following the checklist. We always work as a two-person crew, making sure that, yes, I'm going to throw this switch. Do you agree? Let's throw this switch. And that's how you keep from making mistakes. So here you see Dave leaving the flight deck. The ladder is used actually to ingress from the ground, but on orbit it made a nice little handhold. We used to play games in the little bit of free time we had, to see who could start on the flight deck and go all the way down without touching and land with your feet in the foot restraints. All kinds of little fun things that you get to do on orbit. This is our tool chest with all of our tools for any repairs we needed to do. You can see foot restraints are just put everywhere so that you need to be able to restrain yourself on orbit. And here you see, like I said, the 2 sleeping bags. And then this is the airlock, which is where the space suits are stowed for the spacewalks. And then this hatch closes. When you get inside, you close this hatch, and then there's another hatch to exit to go out into the vacuum of space. And as I said, this was also one of our crewmates' bedrooms. On-orbit repairs, even now on the space station, they're finding out that people have really good skills working with tools. There's always things that need to be fixed. The shuttle, not so much, but like on board space station. And then we had to always clean out all of our filters. I thought I was going to get away from vacuuming and cleaning for at least a couple of weeks, but no such luck. But at least you could float up, which made it a lot more fun. As you can see, Dave here, our commander believed that a clean ship was a happy ship. And it really is important. Cleanliness and stowage and garbage management is a really big deal on the space station. The way we did our meal preparations was we would, Dale Gardner always did breakfast because nobody got up early and made coffee fast enough, But he always did breakfast, and the rest of us would take turns working together, getting out whatever the meal was for the day, putting the trays on the restraining them, and then heating them. But when we were very good, our commander liked to reward us in a very special way. And these are our special candy-coated chocolates, which I'm sure you'll recognize, but we're not supposed to advertise. But as you can see, it's a lot of fun. Try to be careful. You never know exactly what you're taking in, And as I said, here's Dave studying fluid dynamics. And we are now actually on space station doing a lot of scientific studies on how fluids and flames and all that sort of stuff act in zero-G. As you may have heard, recently on a spacewalk, one of the crew members got fluid into their helmet, and it turned out that we didn't understand. I'm going to stop this here. That we really did not understand the way fluids act on orbit, and if you have some questions about that, we just had a briefing on what happened with that suit failure. And one of the key things was what the engineers thought of how that fluid was going to act in the suit and how it actually behaved in zero-G was very different, which led to some of the problems, but I can talk about that a little more later. Now, one of the real benefits of our training was becoming a good photographer. I wasn't a very good photographer when I started my training, and every photographer wants to try to show you the photographs that they take. And so I'd like to share some of my my vacation photos, if you will. Every photographer wants to capture a beautiful sunrise or sunset, and here you see a sunrise or sunset. Can't tell which way it is from here. But the thing I use this to remind me of is that you're going to see a sunrise or a sunset every 45 minutes. So no matter what you're doing, if you can, you try to stop because it's so incredibly beautiful. The Aurora Borealis. This is looking into the Mediterranean. I think most of you will recognize what this is, perhaps. Great shot that my office mate Randy Bresnick took from his flight of Israel, looking at the Sea of Galilee, the Dead Sea, and the Red Sea. What always, well, I'll do it, I'll talk like that. And then there's another view this part of the world. One of my favorite memories was one night, every night before we went to bed, we would take like one orbit, an hour or one orbit or so, to just look out the window before we went to sleep. And one night we launched with a full moon, and I looked out the window, and it was a full moon, and it looked like there were some clouds, and I looked over to the world map, and it was really the Himalayas, the snow-capped Himalayas with the full moon, and it was just incredible. Just wanted to share, I'm not sure exactly where this is, but it's in the Mediterranean, probably some of the Greek Isles. Maybe someone here will recognize and can tell me. I've been asking all my fellow astronauts, and nobody can actually tell me where that is. That's Greece is what I was guessing, but I didn't want to say it. But this is what the daytime views from space are beautiful, but the nighttime views are absolutely spectacular. And this is what the cities look like. This is Tokyo and Tokyo Harbor. I'm sure you all know this, the Nile River Delta. And it's amazing. Africa, it was totally black except for the Nile and the Nile River Delta. And then the other spectacular thing about Africa was the thunderstorms. You would see a storm and lightning in one part, and all of a sudden the lightning would just propagate over hundreds of miles, and you could just watch it kind of travel down the length of Africa. It was just incredibly beautiful. This is Florida looking up the east coast of the United States. Not sure what was happening there. This is Los Angeles, where I grew up for a part of my youth anyway. And the thing that I always am so amazed is when you look at a city from space, how such a populated area, you can, just looking at it with your bare eye, you really cannot tell that there's millions and millions of people in that area. And then this is the Kennedy Space Center. Here you see the two launch pads, 39A, 39B, the vertical assembly building, and the 15,000-foot runway that the space shuttle lands on. And I'll use that to remind myself to say that from the west coast of the United States to the east coast takes about 8 minutes. Just about the same time that it takes to go from 0 miles per hour to 28,000 kilometers per hour at your orbital velocity. And that takes, in all kinds of rockets, takes anywhere from 8 to 9 minutes, depending but roughly, which, you know, once you're going from one class to the next, that's about the time that you're given to change classes. So that gives you an idea of the kind of speeds you're dealing with. So from our flight, we worked very hard for 7 days, and then on the 8th day was just a day to kind of clean up and get ready to go home. Got to talk to the president at the time from space, which was really cool. Everybody placed to get their good pictures. And then finally, on the morning of the 9th day, we did our deorbit burn. And you have to be, the targeting for the deorbit burn, you know, is done very carefully. And then once you do that deorbit burn, and you slow down your vehicle, then you are re-entering the Earth's atmosphere, and you really hope that the flight controllers who did the targeting did their job very well, because you're going to be landing somewhere, and you just hope it's on a runway somewhere. We landed at the Kennedy Space Center, and as I mentioned, we were the first crew to bring hardware back from space, and we had customs officials asking if we had anything to declare. But one of the things I think most crews worry about, and now for space station, you'll see that the crews, and if you look at the Russian program, you don't see people coming down from space and walking down the ladder like we were doing, because it might look like we were steady, but we were not. My biggest fear was I was going to fall down. I don't, camera with people taking pictures and stuff. Because when we landed, I felt like an 800-pound gorilla. I had switches that I had to throw on the overhead panel that took me 30 seconds in the simulator, if that long. It probably took me 2 minutes to do all those switches to get my hand in the right place. So definitely you don't want to come back and have to do an emergency egress and jump out, because you're just not very steady on your feet. For the crews that come back from the International Space Station that are up there for 6 months, we have a very special program with special trainers that work with them for at least a month to 6 weeks to get them back into shape. And then, as I said, I was the first mother in space. We landed at about 7 or 8 in the morning, and by 1 or 2 o'clock in the afternoon, we were back at Ellington in Houston. So it was. And these are my daughters now. I always get questions about so I just always include both of them. I'm just going to really quickly go through training. And feel free later to ask questions. Here you see one of our simulators. We spent hundreds of hours. In my crew, there was a 3-person crew for ascent entry, the commander, the pilot, and me. I was like the flight engineer. And then Dale and Joe were doing the spacewalk. So basically, we didn't train together very much. The 3 of us had hundreds of hours in the simulator. But as you can see, this looks almost like a real vehicle. You practically can't tell that it's a simulator. But then also as part of your training, you're also not just training the crew, you're training your flight controllers. And so at each one of those positions is somebody who's responsible for the computers, for the electrical system, or all the different systems on board the shuttle. And we have the same setup for the space station. And so when we're doing what we call our integrated sims, we had sims where we did it just by ourselves, and then we would have integrated sims to where we trained the whole team to work together. And so, and there's a flight director, because it is definitely a team effort between the 2 people in charge, which is the commander and then the flight director. And then this is a shot of the Capcom. And one of the best training you have for going into flight is being the Capcom, because you really need to understand how the mission control works, how they make their decisions, so that you really trust them when there's an emergency or something, or if they say stand by, and all of a sudden 5 minutes go by and they don't answer. If you've worked there, you really understand better how things work. We also have another set of simulators. These do not actually have switches that work, but this is where you do work on your stowage. It may sound like a little thing, but particularly your first day on orbit, if you get off to a bad start on that first day, then you'll kind of feel like you're behind the curve for the rest of the flight. So we would work very hard on how your things were stowed, what you were going to, how you were going to get everything out, how you were going to get the potty activated so that everybody could go to the bathroom quickly, how to take those orange suits off very quickly, and all that. And that first day was very, very critical. This is where we would actually bring all that stuff over and practice doing that. We also have a full-scale mock-up for the International Space Station. And as you can see how large that is, and we can do all of our training on that facility. This is where we did a lot of our emergency egress. For example, if the shuttle went off the runway and the hatch was distorted and you couldn't get out through the hatch, we had techniques using the back mountain climbing kind of things where you could come out. There are overhead windows here, and we'd actually have to go out over that, and that's where you're practice doing that. We also have a very large pool called the Neutral Buoyancy Lab, which is has like over 7 million gallons of water,
And you can see here's a mock-up of the shuttle payload bay and a mock-up of the space station. And this is the facility where the crew members train for their spacewalks. You get into the suit and you can see they have these little lead weights. And we have very skilled divers that learn how to put those weights on you so that you can practice being neutrally buoyant. This is probably the most difficult training we do physically. And get a lot of injuries on shoulders because of the way the suit is built. And we're trying to change that in the next suit that we build. And then here you see them practicing whatever the particular task was. There's a safety diver for each person. But this is, like I said, probably the most physically demanding training we do. And then we also use that facility and others to practice our emergency egress if you had to eject from the shuttle or if you had to eject from T-38s. We also have a fleet of T-38s, which is where the pilots use to maintain their proficiency. And for the mission specialists like myself, who've never been in a high-performance aircraft, this is the one thing we do where you're not in a simulator, where you can kill yourself if you don't follow the correct procedures and check weather and all that sort of thing. So it's really valuable training. And even get to do fun things like parasailing. And only the difference was on this thing you had to actually cut yourself loose, and then you landed in the water and had to climb in the raft, and then a helicopter came and picked you up. It was a lot of fun. I'm just going to run through real briefly now, just talk to you a bit about the space station. The space station is an international effort, as I'm sure many of you know, with the Russians, with the ESA, the European Space Agency, and with the Japanese Space Agency. We launched the first elements of the space station in 1998. There were two, the functional cargo block from the Russians, and we launched Node 1. And then there was a 2-year period where I was chief of our space station branch, where we actually developed all the procedures and all of that sort of thing, and launched the first crew. Here you see the first crew going up to the space station in October of 2000. And then the space station has been continuously manned since that time. What I really enjoy about the Russian program, as you see here, this is just pretty shortly, maybe a few hours before launch. And as you can see, there's all these people around. For the shuttle program, when you went out on the morning to launch, there was nobody there. There was just the crew of people with you. And it was, to me, it was actually scarier. You know, that just makes it seem really scary when you go out there and you're used to seeing hundreds of people working on the shuttle, and all of a sudden you go out there and there's nobody there. And so I think the Russian way on this part of it is kind of interesting. Sergei Krikov, who was, at that time, it had more hours in space than any human, but I think he's probably been surpassed now. Shortly after that, we launched the U.S. laboratory. You can see how nice and pristine and clean it looks like when you're moving into a new apartment. It does not look like that now, let me assure you. Here is a later version with all the equipment as we start outfitting it. And now I'm sure I'll show you the video in a few minutes of what the station's like. It's definitely a lot messier. We try to be very good housekeepers and everything, but it gets hard in Synergy. Then we launched the Canadian arm, which we had an arm on the shuttle that I mentioned, which we called the little arm, and this is the big arm. Now we no longer have the shuttle arm, but we still call this the big arm. And this is a view looking at the, from the front. I mean, obviously, you could orient the space station any way you wanted, but we choose for many reasons to fly it in this configuration. Here is the Node 2. This is where the shuttle used to dock when the shuttle was coming. We have the European Space Module, the Japanese module, and it's flying this way. This is the forward portion of the space station. And here you see that Node 2 and looking over into the European module from the Japanese, no, looking over to the Japanese module, you can tell because it's got this little airlock here. And then this is a view from the back, or the aft portion of the space station, which is more the Russian segment with the, and here you see the inside of the service module. This is where the crews get together to eat, and they always have their pictures of Gagarin. You can see the look inside the Russian part is very, has a very different feel to me than the US side. exercising is really important when you're going to be in space for 6 months. We have this device called the ARED, the resistive exercise, the astronaut resistive exercise device, and it lets you simulate weightlifting here on the ground. And then we also have a treadmill. Sonny Williams actually ran the Boston Marathon on the treadmill. Each person on board space station has a sleep station. There's 2 in the Russian segment. Those always go to cosmonauts. So far, to my knowledge, no non-cosmonaut has used one of their sleep stations. What's neat about their sleep stations, they have windows. The Russians, one of the other things that I think they do very well is they understand human psychology, and having that window there is really nice. And then in the U.S. side, in Node 2, there's 4 of these little phone booth kind of size sleeping compartments, and there's one on the right port, on the starboard side, one overhead, one on the deck. They're just in a circle all around, and everybody has their own sleeping station. Everybody has a laptop. You can get we now have connectivity to the internet, although it's kind of protected to protect against viruses or hackers coming in. But everybody has their own laptop. We have phones where the crew can call their families. I've gotten calls from space from my friends, which is really cool. But you can't call the space station. They have to call you. And then just some really neat shots of the space station, just to see how big it is. The habitable portion is about the size of a 5-bedroom home here on the ground. You can see this is where one of the ports where the Soyuz docks. This is the cupola, which is a really neat feature that was added with the windows all around, plus this window here, and I'll show you a slide of that in a moment. This is the cupola, as I said. This is everybody's favorite place on board space station, and you can see why. You can see the great views. And then you have that one view looking directly down, and whenever anybody has a spare moment, that's where they want to spend their time. But it's also where you operate the robotic arm from. Is from mostly, you can operate it from, there's 2 stations where you can operate the arm. One is in the lab, where you can only have cameras, no views, but obviously the preferred one would be here, where you can actually look out the window and see what you're doing. And I just include this because it's an artist's depiction of what the station was going to look like way back when, before we even started building it. And I think, although there are differences, it looks very similar. So like now, when I'm looking at artist pictures of what we're going to do in the future with Orion and so forth, it gives me hope that we're going to actually do this, because we did do that with Space Station. This was the last shuttle flight, was STF. We flew 135 shuttle flights. And this was one of the last views taken of the space shuttle on the pad. And now, of course, the United States, anyway, does not have the capability yet. We're working really hard, I'm going to show you that in a minute, of launching humans into space. We can launch cargo. So in the near term, we launched with the Soyuz rocket from Russia, from Baikonur. And one of the things that I just find so amazing in working with our Russian colleagues is about 2 years ago, they launched a Soyuz in the middle of a blizzard. I mean, the astronauts actually had to come out with their suits on and have some of their protective gear on. It was so cold, and yet they launched and launched successfully. And you got to hand it to them. They developed really hardy equipment. Now I'm going to give you this quick tour of the space station, because I think it's really neat to see it actually. And it's narrated by one of my colleagues, one of my office mates, Butch Wilmore. And I think it'll give you a feel of what it's like to be on board the space station. Not sure. Well, we're going to try to. Sorry about that. It doesn't look like it's going to work. Sorry about that off to, so when I checked it out, it was all working, but not quite sure what happened there. But anyway, sorry, I won't be able to. Sorry. So anyway, what I'd like to, right now, this is the crew that's on board. We're up to Expedition 38. The way things work now, you have a Soyuz. A Soyuz carries 3 crew members at a time. So this crew was a Soyuz crew, and this is a Soyuz crew. And at this particular time, Expedition 37. So the crew on the left, came back down to Earth. This crew remains. There's like a 2 or 3 week period where there's only 3 people on board station, and then the next crew launches. And this was Expedition 37. And now we're currently in Expedition 38. This is a crew that launched just about 2 months ago. And this is the crew that's currently on board the station. This is the first astronaut from the class of 2009 that was selected just for going on the station. They did not actually have shuttle training, and that was the first one of their group to fly. So this is the crew that's currently on board station right now. When you depart the station, this is what it looks like. The Soyuz is a much smaller vehicle than the shuttle, and you can see how crowded it is. And then they land with a single parachute. The Orion vehicle that we're designing, and I'll show you in a second, has 3 parachutes, but they've had no problems with it. And everyone who has had the opportunity to ride on this says when it hits, it feels like a car crash. I mean, and they fire little retrojets to soften the impact, but even so, it's still is a very difficult landing. As I said, the Russian program does not have people walk over to where they're going. They put them in these little chairs and transport them. And after 6 months, it really is hard to walk those first couple of days. Real briefly now, I just want to mention real quickly where the United States program is headed. We're building a vehicle to go beyond low Earth orbit, and I'll talk to you real briefly about what we're going to do about trying to build a vehicle to go to the space station. We decided, they did an extensive review to see what would be the safest vehicle, and they went back to a capsule. It's pretty much just like an Apollo capsule, only it is a lot bigger. It has the neat thing about it, which makes it safer, is a launch abort system. And with the launch abort system, you can press a button on the pad, and it'll just pull the entire vehicle with the crew away, and then you just have a normal landing the way it would normally land, which was something that we did not have with the shuttle. This is our first mock-up. I'm currently actually working on the displays that we're designing. Unlike the Russian program, our program is planning to land in the ocean off the coast of California, off the coast of San Diego. And then we have these balls that are uprighting systems in case you can land sometimes inverted, sometimes on your side. And so they have an uprighting system. And this was really testing the uprighting system. So I said I'm working on the displays, development of the displays for the vehicle right now. And this is a test we were doing recently, our first integrated look at those displays. And hopefully this vehicle, there's a lot of political debate in the United States about where we're going to go. I certainly hope that we go back to the moon, but there are others who want to, go to asteroids and those kinds of things, and that's still being discussed by the politicians. And then our ultimate goal, of course, is to eventually go to Mars. It's very possible somebody in this room might be the very first part of that first crew, and I'm really jealous. I'm not going to talk too much about this, but the other concept in the United States that we're following is the government, NASA, is developing our vehicle, the Orion vehicle, to go beyond low Earth orbit, and we're handing over to the commercial world to build a new vehicle to go up to the space station to take humans into low Earth orbit. And we had a program which is very different in the United States. The way we normally did space vehicles, we would contract to a contractor that was selected, and they would build a vehicle. We're not doing that anymore. We had several development runs where with these two, the Commercial Crew Development 1 and 2, they let contracts, and they just were looking at the vehicle for the without the launch vehicle. And then we finally went to this integrated capability, which is the vehicle plus how they were going to launch, what rocket they were going to launch on. And at the moment, we have 3 contenders. SpaceX, which I'm sure most of you have heard about, they already have successfully launched cargo to the space station. Now they're trying to turn their Dragon vehicle into human-rated vehicle. Then we have Sierra Nevada, which is basically a smaller space shuttle type vehicle. It will only carry, it'll be designed mostly to take people on orbit, although you could probably have an unmanned version that took cargo as well. But the plan is predominantly to bring humans up to the space station. And then last, Boeing is building another capsule type vehicle, not that dissimilar to what we're doing for Orion. We're right now in the process of letting out contracts and deciding. There's a lot of discussion in the United States. I have no idea how that's going to come out, but there's now currently a board trying to decide which of these proposals are going to go forward, 1 of them, 2 of them, how much funding, and all of that. I'm sure 1 of them will be successful. They're all very, this isn't like new technology that they're developing. And then they're using, SpaceX has developed its own rocket, the Falcon 9. Sierra Nevada and Boeing are both using an Atlas, which is a proven rocket that's been launching satellites for a long time. And so that's the Commercial Crew Program. So that's where the United States is heading. I just want to mention, the reason I'm here, we're having a conference where we're remembering Ilan Ramon and all of the crew members, because as we go forward into space exploration, I think the way that we honor those that we've lost is by continuing to explore and to carry their memory forward. And this is the Conjo crew with Ilan. And I'd like to close with this slide. My grandmother passed away in 2003. She was 105 years old. She was born in 1898. I look at that and I say that's where she started with the horse and buggy days, and she got to see the development of commercial flight, rockets, and then the space shuttle, and finally lived to see her granddaughter go into space. And I'm sure she never in a million years, when she was growing up in Germany, thought that that was going to be a possibility. And the thing I just want to say to particularly the young folks in the audience is just, with the rate at which technology is changing, I cannot possibly imagine what you are going to see for those of you who are lucky enough to live 100 years. It's just an amazing time to be alive, and I just urge you to study real hard in school and follow your dreams. I had no idea when I was studying at your age that I would have an opportunity to become an astronaut. I mean, it was something I dreamed about, but to think that it was really going to happen, and as I got into my training, I never thought that that was going to be a possibility. And so you never know what the future holds. Like I said, maybe one of you in this room is going to be part of that first crew to go land on an asteroid or go to Mars, and I certainly will be cheering for you if that's the case. So anyway, just want to thank you for your attention. I'm sorry for the one video that you didn't get to see, because maybe some of you in here would actually like to go beyond the space station. And it is really an amazing vehicle. And we get to do a lot of neat things. So anyway, I think I've talked enough. I'm going to be happy to take questions. And thank you so much for your attention.
Two or three questions, so please start first.
I think it is interesting to hear your point of view about some philosophical questions. How you define to yourself the size of the universe, and how you imagine what we have beyond the universe?
Boy, that's a tough question.
For now,
sorry.
I had an opportunity about 2 years ago to go to a planetarium on a trip to Hawaii. I was doing something like this talking, and they gave a presentation showing the universe and how vast it is. And just for me personally, to me it's almost incomprehensible how big the universe is. I just hope that eventually we're going to get to at least go beyond our solar system. And I'm just, for my personal, I'm just happy to be part of the first steps in moving our planet. The fact that I just had to have a chance to do that is my dream. And I just hope that eventually, years from now, we're going to be people who get to go beyond. But I really don't know how to monetize it. It's more than my mind can grasp.
How did you get involved in this
The question is, how did I get involved with the space program? When I was 12 years old, I was in 7th grade at Fort Campbell, Kentucky, and Alan Shepard was launching. And I remember, you know, back then we didn't have all the TV coverage and the internet and iPhones and all that. And our PE teacher, we were outside, and she had a little transistor radio. We're all sitting there listening. And I heard that, and just at that moment, I just said, I want to do that. I want to be on a rocket and go into space. But, you know, at that point, it didn't seem like a very realistic goal. All the astronauts were male, and they were all fighter test pilots. And for some reason, it occurred to me to go to medical school and become a doctor. It never entered my mind that I could maybe be a pilot. That just, you know, I was that much conditioned by societal expectations that it just didn't even enter my mind. I knew I was good at science and math. And as I went on to my career and I got into UCLA, there weren't a lot of, you know, at that time there weren't a lot of space stations. So I just thought, well, I was perhaps born too early for my dream. And then I was in the middle of my medical training, and one of my friends, I really found out about it very accidentally, that NASA was looking for not only pilot astronauts, but mission specialist astronauts. And I got my application in the day before the deadline. And that was in June of '77. And in August, which a few weeks later, I was in Houston interviewing for the biggest opportunity of my lifetime. Never in a million years thinking I'd get selected. So that's why I say just always keep all your options open. And, you know, if you have some dream that you think is impossible, you know, just keep it in the back of your mind anyway and don't give up, because I was just really
with technology and the rate of its development, how far do you think we will go? Mars, the solar system, everything?
I for sure think we can go to Mars. The problem with going, I mean, there are technologic challenges for going to Mars. You know, one, we need to solve radiation and radiation effects on humans. The loss of calcium from your bones. And then probably the biggest technical challenge is the propulsion system. But Franklin Chang Diaz, which is one of the U.S. astronauts, is working on a plasma ion engine that looks like it's very feasible. So I think the technological challenges for going to Mars are certainly difficult, but they're well within the capability of what smart people like you will be able to solve. I think the bigger problem is the political side of it, and the financial aspects. You know, no one nation can, at this point in history, I think, afford to pay to go to Mars and do all that development. So it's going to have to be an international effort with all the economic challenges that we're facing, you know, certainly in the United States and in other countries as well. I think that's the biggest challenge. If we can figure out that, and then the whole politics of, okay, now we've decided to go, we're going to pay for it, now how do we pick who's going to go, you know? I just think it would be very interesting to be on the board that selects the crew for that mission. You know, what size is it? what kind of specialties. I can tell you one thing for sure, there'll at least be one doctor on board, medical doctor, and probably two. So, you know, if I were going to increase my odds of going to Mars, I would probably, you know, study medicine. But anyway, I think the challenge is in that. Then going beyond Mars, you know, to get out of our solar system, now we're into a realm of technology that we don't even have existing today, or even know how to do that. But I do think that, like I said, with the change in the rate of technology, I'm sure that humans in the future will solve those.
How was it living with family and especially program and while you know
That's a good question, and it was one I dealt with a while. The hardest thing of all for all astronauts is leaving their family, and particularly even now for the space station astronauts, they train for at least 3 years, and they're gone at least half the time, and then they go into space for 6 months. It's very hard on families. The technology, the internet, Skype, and FaceTime, all that kind of stuff really helps. You know, I didn't have all that when I flew, but I really didn't have to travel that much. So I was mostly gone for that window, the 2 weeks of quarantine on my flight. But the rest part of it was definitely something, you know, I struggled with. But I had made my commitment to NASA, you know, before I had my daughter. I knew my daughter was in good hands with my husband and my mom, and she had good support there. And you know, you always think it's not going to happen to you. It's always going to be somebody else, right? So I think the human mind has this capability of disregarding that, you know, that thought. But you know, I took a lot of videos that year. You know, I don't think I really mentioned, but I was assigned to my flight 2 weeks before I delivered. So I was a new mom, and I was training for a flight all at the same time, which was really challenging. But at the same time, I didn't have time to sit around and think about things too much. But it was very hard. It was hard to leave her, but I love space. I love the space program, and I believe in it very strongly. And I certainly didn't want anything to happen, but I understood that was a possibility, and I believe in it so much that I was willing to take that risk.
Thank you very much.
I just brought this presentation to present to the Hebrew University, and that's a phone bag, flag of the United States, and a patch from my mission that was a photo on board the shuttle.
Thank you very much.
Okay, so everybody stay in their seats quick. She's going to come up here. We're going to take a picture back so that everybody can have a picture. We'll take. Come on out. Take a couple. Which photographer? How you want to retire? Yes, you will. Sorry?
Yeah. Okay, and you can walk towards me now, please.
Thank you very much. Thank you very much.
Anna?
Look.